All right, hello, welcome, and I think we're all set on the live stream. Again, this is now my second YouTube live stream. It takes a little getting used to. I still have some stuff I'm figuring out, so thanks for your patience on getting everything going. I'm seeing a lot of people chatting about the CCNA, and I think I saw some conversation about the fail one, get one test code. So here's the story on that. There was, and I actually posted a little while back a test code that somebody gave to me. It was actually somebody gave me a link to a Reddit post where somebody said Cisco's having this promo, all this kind of thing, and I was like, great, and I stuck it in there, and it was a fail one, get one. But apparently Cisco had only given that to a select group of people. And they contacted the person who gave it to me, the person who gave it to him, and they were like, that's not supposed to go out. So if you have that code, great. It works, and the way it works is if you miss the exam, and that's either ICND2 or CCNA. It doesn't work for ICND1. If you miss the exam, the next time you go to reschedule it, your take number 2, use that code, again, if you have it, and that will make that at no cost. But as somebody said, there is a 5-day, I think, retake window. They don't let you just come back and take it like a day later or something like that. So keep that in mind when you're doing all your scheduling. So that being said, welcome. We are trudging through our practice exams. I've got another practice exam set for us today. I am doing this because I know a lot of people are on the bandwagon of I'm getting my CCNA before February 24th or February 23rd, if you will, because that is when the old CCNA goes away and the new CCNA takes hold. The new CCNA, nobody has seen it yet. So I get a lot of people that are like, is it going to be harder? What's on the exam? It doesn't exist yet, as in nobody can take the exam. We've got the curriculum that it was created from, and the Cisco Press certification guides have been published. Keith Barker, Chuck, Keith, and myself, some people know him as the Network Chuck, and myself, we created the brand new CCNA series at CBT Nuggets, and it is very similar to the old one, just with some new stuff on automation, which we'll talk about there. So I'm doing this to try and help those that are racing for the deadline to get everything that they can to help. So the way that I do this, if this is your first time with us, is I go in and I walk through a practice exam. I ask you a question, give you a sec to answer, and let me actually, I'll post it again to the chat. Join this link. I just posted it right there. Join that link if you want to jump into the game. It's just a game that we play where we kind of do the points. I'm going to see if I can show the score as we go. I'm just nervous to do it because last time I tried to do it, it ruined the quiz. Like we had to start it over. So I'm going to try hopefully and do it because it's kind of fun to see who's winning and stuff like that before the end. Obviously you win a wooden spoon. Thank you, Spring Mommy, on what that. So the sacred wooden spoon is there. Okay. So, I will, hang out. I'm not sure if I'll be able to stay the whole hour this time, but I'll hang out afterwards for questions and I'll try and answer anything that I see as it's flying through. And go from there. So yes, 12 days away. All right. So that said, the exam that I'm using is on the CBT Nuggets website. With every CBT subscription, you get access to the Kaplan practice exams. And what I did was literally generate an exam straight from there. It's got a bank of like 600 questions, and I just grabbed 30 of them that it pulls at random, and that's what we're working through. So we'll work through this one right here. Let me go. Which of the following is not an advantage of static routes over dynamic routes? Ready, set, go. All right, good. So, thinking through this one, it's asking which of the following is not. This is what last week we ran into this, and sometimes I always say half of the game is understanding the question, the other is the technical knowledge. So sometimes the way it's worded is really tough. So, which of the following is not an advantage of static routes over dynamic? Okay, so routing protocol overhead is not generated by the router. So, which of the following is not an advantage? So, routing protocol overhead is not generated by the routers. See, this is the thing. It's funny. I just now I'm reading these answers. I'm like, okay, double not. So I'm going to say no, it's not that one because an advantage of static routes is that there's no routing protocol. But I'm telling you, my brain doesn't work when you start throwing the double negative at you. I'm like, I don't even know what they're saying anymore. Static routes are easier to configure and troubleshoot than dynamic routing protocols. That is true. That is actually truth, and that is an advantage. So that's not right. Static route configuration is more fault tolerant than dynamic routing protocols. No, that is not an advantage. Now you can do a floating static route. Let's just say you've got two ways to reach the same network. Let's just say 10.1.0.0/16, for example. You can do a static route this way and a static route that way for some fault tolerance, and it'll do load balancing. Or you can use a floating static route and make the administrative distance, meaning the believability, higher on one of these, because by default, the believability is 1 on a static route. So you could just make it a 2. And that one won't be used until this one goes down or is disconnected. But it's not an active pulse, meaning when you're working with a dynamic routing protocol, it's sending hello messages over those links all the time. The static route, sometimes it can't tell if the link is actually down. It can only tell if it gets a physical disconnect on that interface, like it loses the carrier signal. So this guy right there would be the most likely one. Let me just look at the last one. Bandwidth is not consumed by route advertisements between network devices. No, so an advantage of static route is there is no bandwidth consumption. So I'm going to go with C on that one. Bingo. And we got it. So looks good. Actually, I was going to try and see if I can see the results of. Here we go. It's look. Oh, that's cool. That's cool. All right. Look at this. Let's see if I can do it every time. There we go. Hey, look at that. So Tom D in the lead. Elliot, I think Elliot took the wooden spoon last time on the score. Cool. So I think that'll work. All right. So question number. And actually, hang on. Any questions? Oh yeah. By the way, if you're typing the answers in the chat. That was misleading a whole bunch of people last time. Jump in the game rather than typing it in the chat, and we'll go from there. All right, cool. Greg, you're gonna do awesome. Okay, so next question is right here. Which of the following commands? There we go. Which of the following commands would allow you to determine the bandwidth of an interface? Ready? Go. All right. I think I killed the quiz. I told you I was so excited. Hey, I can see the answers. So I tried to start the quiz again, and let's see if sorry, fix it. Yep, I blew it up. So I think I've got it now, and we'll go from there. So girls, don't try and run the quiz because I think I have to run it here in order for it to work. Okay, so did that work? I think it's working. All right. Sorry, I'm still trying to figure out the quiz. So it looks like it's going, and let's look at the questions on here. Or the answers on here. Which of the following commands would allow you to determine the bandwidth of the interface? Show interface accounting. Actually, you know what? It would be awesome if I could get a live router going. Let me do this. I'm gonna launch one of the labs that we have at CBT Nuggets, and that way I've just got. There we go. It's loading up now. There we go. Cool. So that way I'll have some live routers to show you these commands on. So show interfaces accounting will show you packet statistics and things like that are going through, but it won't actually show you the bandwidth configured on there. Show CDP neighbors and show CDP, also incorrect. That'll show you just the directly connected devices, and that's all show CDP neighbors do. So if you were sitting on this router and type that in, you would see these devices connected. This shows you the timers that CDP is running, but it won't actually show you the bandwidth. The correct answer should be show interfaces. That will show you the that'll show you the bandwidth that's configured as well as the load itself. You can see right here the that's funny. This actually is different. On a real device, and I'll have one coming up for you in just a minute. On a real device, it will show the TX load and the RX load, which is the send and receive traffic on there on a scale of 1 to 255, where, again, I don't know why Cisco did it this way to make it, I don't know, more granular. So Joe's like, I got it wrong. I'm glad it was broken. This would be virtually unused, 1 out of 255, whereas 255 out of 255 is 100%. So that tells you the actual utilization of that interface. Good. Okay, cool. So here we go. Now I got a live router at you. So I'll do a show IP interface brief just to see what interfaces I've got. Let's do a show interface gigabit 0/0. There we go. There we go. This is what you would normally see. That's why I was a little thrown on the exam output right there. It will show you not only the bandwidth that you have configured on that interface right there, but also there's the TX load and the RX load on a given interface. So that's a great one. Cool. All right, good. All right, next question. Here we go. Question number 10. Which of the following statements are true of default routes? Choose two. Ready, set, go. Guys, I think I broke it again. Did it? All right. Girl, I'm not gonna post the winners because that's where I think it breaks. Girls, you run the quiz and go from there. All right. Sorry, guys. Here we go. We'll get it launched one more time. All right. I've got my girls running the quiz now, so I won't be able to show who's ahead, but that's all right. So jump in the quiz. It should work now. All right. So which of the following statements are true of default routes? Let's walk through it. Networks. So first off, let's not walk through it. What is a default route? So when you're sitting on a router, and let's step back even another level. What is the whole purpose of a router? A router allows you to segment networks and allows communication to pass through those networks. So if I have, for instance, my site right here, we'll just call it site 1, right? Where I've got all my users and they're happily doing their computer work. And then I want to connect that up here to site 2. That's where the router comes in. The router will allow you to bridge those two sites together and allow the communication to happen. Well, site-to-site bridging is becoming less and less and less and less. That's because the internet is now everywhere, and rather than buying these private WAN links, which still exist, but a lot of organizations are opting for internet and VPN connectivity and things like that to connect their sites. So what you would have is you would have that site, we'll say both of these sites, connected to the internet. So a router, you have to go into that router and say, pretty much educate it. And that's kind of goes along with the last question we were talking about, static routing versus dynamic routing. If this network up here, let's just say this is the 10.1 network, right? We'll just say /16, just be crazy. I'm writing in my head. 10.2 network right here, right? In this office, I could go into this router and statically say, to get to the 10.1 network, go to this IP address, right? Or I could use a dynamic routing protocol like OSPF and allow these guys to chat amongst themselves and kind of figure it out. They exchange what networks they have. A default network comes into play when you're saying, okay, for everything else, everything that's left over, 0 to 0, everything, you will go this direction. And that's really useful for a network that is too big to describe in dynamic or static routing on your router, the internet. This is kind of a catch-all. Send anything that you don't know about off to the internet. So, first one, which of the statements are true? Network security is increased by using default routes. No. Actually has nothing to do with network security. Although one could say, well, it'd be more secure if you had no default route because then you couldn't connect to the internet. Fair, but it's going extreme. Default routes should not be used in a stub network. Should not be used in a stub network, which are true. So let me draw that. A stub network is where, so OSPF, when you're doing OSPF design, this is OSPF area 0. That's considered the backbone. You got all your routers in here. A stub network is where you break your network into another network, and you limit the number of routes that come in. So you would have a router right here. This is your router connecting from area 0 to the stub. And the whole purpose of the stub is to limit the number of routes that end up in here because you want to keep these routing tables small. Looks like a chocolate chip cookie. For all the routers that are in that stub area. And I know this is kind of esoteric. It's abstract. Just because I'm thinking through the answer. Default routes should not be used, and actually it's the opposite. Default routes should be used in a stub network because all these routers do not have the full routes from area 0. This router right here, which is known as an area border router, an ABR, filters all those routes from getting into the stub area. So they need a default route, and as a matter of fact, the ABR will generate a default route by default. So default route should be used, should not be used. Okay. Default routes, let's say I'm running out of space here. Default routes are used for routing packets destined for networks that are not listed in the routing table. Absolutely, yes. That's what I was saying right here. That's the whole purpose of a default route is for anything that you don't know about, it can send it off to the internet. D, default routes are used for routing packets destined only for networks listed in, okay, no, that's the opposite. So that's the opposite of C. And default routes are ideal. Okay, yeah, so these two, they're opposite of each other, B and E. Okay, cool. So I'm going to go with C and E. Bingo. So that's our default routes, and I think you got it. Cool. I'm looking at the results. We'll have to post the results at the end because I blow up the quiz if I try and pull them up. Okay, so Good. Let me just look at the question. So, quick question for ICND2 DevNet. I'll go back and answer the general questions at the end. I guess the point of this question is to make sure you know what the default route is the way out of a network unless something's specified. Yes, you are 100% right. Good. Stubs are networks that go out to switch/host, but no further. Actually, Greg, let me clarify that real quick. The topic is OSPF. When you design OSPF, you will have areas, and let me actually draw this a little different. You will have areas that are smaller than others. It doesn't mean there can't be other routers in there. Like you could have, for instance, let me go practical on you. Let's say this is area 0, right, of State Farm Insurance. State Farm, right? And this is their or State Family Insurance. State Family. So this is their corporate offices and their headquarters and all the different routes up there. This is their area 0. Then what they do is they break into stub areas for all their regions. So this might be all the little strip mall offices for State Farm in Arizona. This might be Texas. This might be California. There's no way that California would have direct routes to Texas or Arizona. They all go back to the headquarters, right? So we would set these all up as stub areas. It's not that there can't be other routers in there. It's just that the stub area is a dead end. And I think somebody said a cul-de-sac, which is right. So you want a default route to get out of there. You don't need routes from other areas because there's really no way to reach them other than going to the area 0 anyway. Hopefully that makes sense. So good. Let's go on to question number 11. And I'm looking at the time. We're going to go a little bit longer this time. Question 11, which statement is true of CSMA CD, collision detection Ethernet media access method? Ready? Go for it. All right, we fixed the quiz once and for all. So jump in and answer. Sorry, I see everybody's chatting it in, different answers. Jump back into the quiz. It's working again. All right, good. So which statement is true of CSMA CD? So first and foremost, I can't go without saying it. CSMA CD is carrier sense multiple access collision detection. It was the competing technology to CSMA CA, which was collision avoidance, also known as token ring. That's the one who adopted that. And who wants to be a millionaire trivia? Actually, you might need to know this. Wi-Fi. Wi-Fi uses the CSMA CA because only one person can send or receive at a time on a wireless connection. That's why wired connections are always better for devices that are stable, meaning they're not moving around, right? So let's look at this. It is ideal for a switched network environment. Okay, it could be that. It says which statement is true. A switched network environment uses CSMA CD, collision detection, okay. Each station is allotted a time slot where it can transmit data. No. That is not true. That is token ring, and that's wireless. That's by the way how wireless implements it. It gives everybody that joins a wireless network gets their time slot. That's why the more people that join a wireless network, the slower it is for everybody. It requires centralized monitoring and control. Nope. It just happens automatically. So actually, I don't know. It uses a back-off algorithm to calculate a random time value. Actually, that is true. Answer's got to be D. Yeah. So what happens when a device, so we're talking about a hub. So by the way, an icon for a hub is a single arrow. You got all your different computers that are connected to the hub. In that environment, if a collision happens, both devices will back off and start a timer. It's like, I think it's 1 out of 1,000. There's like 1 out of 1,000 chance that they'll collide again. But that's what's used to retransmit data. And that's what happens when you have a collision. So good. Okay, good. So any questions on that? Let me just see. Comet is saying, I'm fuzzy why it's not A. The only reason, and I'm curious if it says it in the description, the only reason why I would say it's not A. So first off, D is an obviously yes, because it is, that is a fact. When it says it's ideal for switched network environment, I would say it is a switched network environment. It's not like something that you're like, oh, well, we'll ideally use it here. Like if you are a switch, if you are a standards-based switch, you are using CSMA CD. That is the technology that Ethernet uses in that switch to manage collisions, right? So I think it's probably, again, just the word game that where it's like, it's ideal. Well, it kind of is. It's not just ideal. Okay, so next question. Question 12. Let's see if the quizzes are working now. Which protocol allows the network to fully utilize standby routers in a redundancy group without administrative burden? Go for it. Good. All right. Which protocol allows you to fully utilize standby routers? Well, first off, this protocol you can cross off your list. There is no such thing as IRDB, or if there is, I've never even heard of it. So these are the 3 redundancy protocols, and what that means, I always call them the default gateway protocol, where if you've got, let's just say you've got a switch, you've got your computers attached to that, your wireless access points, all that. That comes to multiple routers that go to the internet, right? You like that because you have redundancy, but the problem is you can only have one default gateway on all of your clients. So if this is our happy computer, its IP address might be 10.1.1.5 with a default gateway of 10.1. Sorry, I'm trying to turn down the music at the same time as I'm writing. 10.1.1.1. So the problem is only one of these. You know, this guy might be .1, this guy might be a .2. So both HSRP, the hot standby routing protocol, and VRRP, the virtual redundancy routing protocol, do exactly the same thing. They allow you to say, okay, neither router has the .1 IP address. That will be a virtual IP address that both of them answer for, but only one at a time. One of them will be active, one of them will be standby. Difference between these two protocols, this one is Cisco proprietary, just because they were there first. This one is an industry standard, so you can use it between non-Cisco routers. This one, the top one, is the Gateway Load Balancing Protocol, GLBP, also Cisco proprietary, but it is the only one that allows you to actually have one router answer first, the other router answer second, next router answer third, next router answer fourth. So it bounces back and forth between these instead of the standby sitting there idle until the other one dies. Now, the load balancing isn't perfect, but it works. So that's when it says what allows you to fully utilize standby routers without additional administrative burden, meaning lots of configuration. That's what GLBP is all about. So I'm just looking at the questions on that one. I thought on the CCNA, you only need to know HSRP. Oh, by the way, this exam encompasses some of the new CCNA topics. Kaplan removed their old CCNA exam, their old ICND2 exam, and replaced it with this. On the old CCNA, you need to know the idea of GLBP. You need to be able to pick it out of a lineup. You just have to know how to configure it. Yes, Sean, it is very tricky with the wording of the question. And like I said, I always say half of the challenge is trying to figure out what the question's asking. The other half is getting it right. So question 13, we'll go up to question 15. Okay. Question 13, what command disables 802.1x authentication on a port and permits traffic without authentication? Give it a go. All right, I know some people are still answering this question. Feel free to keep thinking about it. But let me talk about it because I know some people are this is one of those like you either know it or you don't kind of questions. So what this is 802.1x. This was originally developed for wireless. A lot of people will say this is the technology behind WPA2 Enterprise or WPA Enterprise, which uses radius authentication. What it does is, and you can use it for wireless or you can use it for a switch port. On your switch, you can say before somebody can actually access this port and use it to access the network resources, they have to authenticate, right? And you can that's where you set up a radius server and all that kind of stuff. Well, for some ports, you can say, you know what, maybe this connects to a printer in the hallway, right? Where it doesn't even support authentication to a switch port, or maybe this connects to video surveillance and stuff like that. So even though you're using 802.1x, you might want to have some of the ports that are forced authorized, and that would be the answer on this one. And to make sure that port is automatically authorized, that there's no authentication needed. This one right here, auto, is what it should be set to if you want to either go either way, to where it's like it will either disallow or allow. So we'll check that one. It should be a yes, and the answer is correct. Force authorized permits traffic without authentication. Good. Yep, normal use of this is configured with 802.1x port control auto. This is not a feature a lot of people use every day, which makes it a little more tougher on the exam. But the good news is it's usually not a heavily tested exam topic. So good. Second to the last one, question 14. You are creating a wireless network for your company. You need to implement a wireless protocol that provides maximum security while providing support for older wireless clients. Which protocol should you use? I think you guys are on it. Evolution Moto Vlogs. That name. You are saying exactly what I thought when I saw that. I go, supports older clients. Intriguing, and I love the thrill seeker. How old is? And you are 100% right on this. How old is old? Kind of makes it, I'm going to say this is kind of an invalid question. You probably wouldn't see something like this on the exam, because if it's really old, WEP is correct. It's not going to provide maximum security. WEP is like you can cut through that thing with butter, like butter, or with butter, because it's that insecure. Like that, but only really old clients would support that. I'd be like, why would you use something like that? WAP, that's not a wireless protocol at all. So we're between WPA and WPA2. The modern standard is WPA2, which I would say most every device should support nowadays. This guy is probably what they're after by saying the older clients. Let's find out. Yeah. So yeah, the WPA was meant to be backwards compatible with WEP, but improved the security. It wasn't perfect, but it was a major step forward. WPA2 became like, that's the de facto standard that we use for just about everything. But that question just I would not call that a Sean. So I would not call that a test worthy question at all. I would say that's a good practice exam question. You wouldn't see that in the exam. All right, here we go. Last question. It is diagram. The diagram below shows the state of the switch interfaces after spanning tree has converged. Based on the interface states, which of the following are true? Choose all that apply. And I'll actually tell you, because they don't have choose all that apply on the exam, they will tell you choose two. Give that a try. All right. Well, I know there's still a few seconds left on the quiz if you guys are jumped into that. I saw a few questions when I was just scrolling back on WPA versus WPA2 versus WPA3. First off, you won't see WPA3 on the exam, but I can talk to that in just a second. WPA, so the big difference between WPA and WPA2 was WPA was designed to be backwards compatible with the hardware that they had on clients that supported web. So here's the challenge. They came out with wireless, and they're like, oh my goodness, web is terrible. What have we done? We need to fix this. Well, millions of people had already bought in wireless cards, so they were like, okay, what do we do? So they came out with WPA, which used an engine called TKIP. That's kind of think of that as like the encryption engine, because it allowed stronger encryption than web, without requiring everybody to buy new wireless gear, right? WPA2 was like, forget it, buy a new wireless card. You need better stuff, right? That's why it was kind of like the older equipment. So that's where WPA2 came in. WPA3, and that's, by the way, again, the de facto standard used by 99% of the wireless world. WPA3 came out at the end of 2018 or so. And it's still not widespread, just because all it does is take your typical 128-bit encryption and increase it to 192-bit and add some other, just increase security. That would be nice, but again, it requires another hardware upgrade. So it'll be one of those things that phases in slowly over time. Good. So hopefully that helps if you were curious on that. Now, this first off, I'll bring in. I'm going to say a shameless plug, but when I'm giving shameless plugs for free stuff, it's not really. It really is shameless, I guess. I created a spanning tree. Hang on, where is it at? YouTube. So if you haven't been to my YouTube channel, you should go there. There's a lot of kinds of fun stuff. So I'm going to bring this over here. One of the super popular videos is this one. It actually came from a live stream. Exactly like this. We were doing a practice session. I was like, can I just teach you spanning tree, how to figure this out? So you can see it was 20 minutes of discussion. I'm not going to do that same thing, but I will say, if what I do is like, oh my goodness, this is so confusing, go to my YouTube channel, click on this. Again, it's free. Take it. That will walk you through a lot of the spanning tree, right? And take you there. Okay, so that said, let me look at this. What is it saying? It's saying the diagram below shows the state of the interfaces. Based on the interface states, which of the following are true? Okay, so I'm looking right here. It's saying, okay, this is blocked. So I'm going to write on this. This is blocked. I like just seeing the X's right here. Okay, so it says which are true. Okay, so first off, you've got a hub in the picture, which is kind of amusing. There is no spanning tree on that. So just imagine as if that was just a cable plugged in like that, because that's really all it is. It's invisible to spanning tree. So if this is blocked and this is blocked, immediately I know that this has to be the root bridge. Why? Because the root bridge will never have a port that's blocked. So I would say that gives us answer B right there. And let's see. What are the other? Okay, so that one's not right. Switch 2. Okay, so the fast Ethernet 0/2 interface on switch 2 is a designated port. So no, that would be a root port if that was there. Fast Ethernet 0/0 on switch 2 is a designated port. Yeah, that would be true. Right there. This would be a root port. This would be a root port. This is a designated port because only one side of the connection blocks its connection. So, hang on. My only hesitancy here is no. Actually, that should be right. That should be right, because I was my only hesitancy when I was looking at this, I was thinking, why would this side block? Because this guy has a direct connection to the root bridge. He should have a bit, but then I was like, oh, this guy's got a direct connection too. So that should be fine. Good. So let's give it a try. B and fast Ethernet 0/0 on switch 2 is a root port. 0/0. No, it's not. That's the designated. Okay, so let's check it. Bingo. There we go. B and D are our correct answers on there. So again, if what I did right there was confusing, I could launch into a whole spanning tree discussion, but it would be repeating exactly what I would do in the video that's on YouTube. So please, that one was so good. So go check that out. Okay, good. So that being said, it is 3:48 right now, my time. Let's just take some questions. I'll take some questions until I'll say at latest would be 4, but until you guys are out of questions. So let's go back on there. So let me be me. So okay, so I'll just go from the last one. So Jamie, so EIGRP is open standard, right? It used to be Cisco proprietary. That is correct. That is correct, Jamie. It is an open standard. Oh, thank you, Adonai. Tom D is our winner of probably a partially rigged practice exam because I think it was broken. I think it lost a lot of the answers early on. So Tom, you are the winner of a broken competition. I can't see the other answers. Who are second and third? Madi and Greg. Great job on the quiz. Why I failed? I just answered the same. Oh, yeah, and I think there may have been a wrong answer on the quiz too. So sorry on that one. If you answered the same, sorry. I'm so sorry. The wooden spoon. Okay, so EIGRP, yes, is a open standard. Yes. Oh, everybody's like, it's wrong. Yes. Sorry. The quiz was wrong. Yes. I think on the quiz, C and D were marked as the correct answers, but it was actually B and D. So let's see, need to touch up. Okay. What's the difference between designated and root ports? That's actually Spring Mommy. Let me answer that one real quick. Cause that's a pretty easy one that I can answer quick. So spanning tree protocol, first step is elect the root bridge, right? I'll just put RB. Because the switches will exchange BPDUs, bridge protocol data units. That's their language. They're like, hello, we're running spanning tree. Inside of there is their election ballot, which is their bridge ID, which is the combination of their priority and their MAC address. I'm dumping a lot on you right there. So they use that and elect the root. So in this picture, we're just saying this guy ended up becoming the root bridge, switch 3, right? Second step is all the switches find the best way to reach the root bridge, and that is by choosing their root ports. If you try and write and talk at the same time, you write things like root ports. So that is going to be their most efficient way of getting to the root bridge. Root port, right? It then goes around and says, okay, everything else will be blocked. But the way it blocks it is it only blocks one side of the connection. The other side will be considered the designated. And the designated ports, by the way, simply mean a port that is forwarding. That is like the hyper fast explanation of spanning tree. So root ports are the port it uses to reach the root bridge. Designated port is just a port that is forwarding. That's all there is to it. But again, I would really suggest going and checking out that spanning tree video to get the whole scoop on that. Good. So I'll be viewing. Yes, Sean, go view that. I'll take this hint. Choose 2. Jeremy keeps choose 2, choose 3. I've not. Okay, so let's just open it up because I'm scrolling back and I think it's just chatter that I'm kind of scrolling through. So, this guy WAN is where I seem to be falling short. Any suggestions on things to really cram on, lab on, etc. WAN is tough. I will say, when I took CCNA, spanning tree and WAN technologies were the hardest ones for me. The other stuff was pretty easy, and easy being relative. So WAN technology, I think the hardest, the old exam has frame relay, which is tough. The new exam does not, but they add other tough stuff on there. There's really no way around it. It's just doing it again and again and again. The way that I finally understood frame relay, I couldn't get it until I finally built it in a lab. And then I was like, now I see how this works. You actually set up a frame relay switch and it all starts making sense. So I know in my ICND2 CBT Nuggets videos, I showed how to build that. I would suggest checking that out and then just, again, doing it again and again. Chuck is here? Chuck is here. How is Chuck here? Chucks! What's in the box, Jeremy? A severed head! So welcome, Chuck. Good to see you. Question regarding around Cisco DevNet. I'm intrigued how you would profile yourself towards you as an employer. You're going to look towards other certs as well. So DevNet, actually, man, I wish I could click a button and have you jump on. Chuck is actually the one who is all in on going after DevNet. And I will tell you that that has been an area I haven't jumped into because I know that I know what it's about. I know how I could get into it, but it's just not something that honestly I've been really intrigued by yet. I know there's a lot that you can do with it, but Chuck would be the best guy to answer like how you would position that for an employer. I think the big thing is you can just interface. So essentially, okay, if I were to say, here's what I would answer, and Chuck can correct me later. I would say, if I was going to an employer, I would say, I can now design a simple interface that you can use to control your routers and switches. And that would allow you to do a couple things. One, for new network administrators, I could limit what they could do where they could just click a button and see some of the common statuses without actually getting full admin access to that. And two, I could, automate a lot of the common configurations, like, give me a report of all the interface counters, click a button and bam, you can get all that back. That's the kind of thing that you can do with the DevNet certifications, and automate a lot of your configuration. That's kind of how I would sell myself to an employer if I was doing that. But Chuck would be the guy to answer a lot of that. So let's see. Hi, Chuck. You frame relay. Okay. I had PADO, QoS, traffic policing on ICND2. Wow. That's interesting. PADO, quality of service, and traffic policing on ICND2. Never even heard of policing until that test. That's surprising. I know it's on the new CCNA because I just taught it. But I didn't know they had added that to the old ICND2. That's new. What's the difference between PVST and RPVST? So it's the difference between common spanning tree and rapid spanning tree. One is just extraordinarily faster than the other. So spanning tree convergence, 30 to 60 seconds. Rapid spanning tree, around 2 to 4 seconds at worst. So can you explain more about DELCs? I can. Let me look at some other questions first. So let me do that. It's just, so I think I can do it pretty simple. And I think I can do it pretty fast. So let's do both. Here we go. Ready? Let me shrink all this down. I'm just going to grab a black screen. There we go. So, frame relay. Here's the flyby concept. With frame relay, you have routers that connect into a service router. And what the service router does is they allow you to essentially connect anything to anything. So you might have your serial 0/0 interface over here, say serial 0/0 interface over here. Now, the great thing about frame relay, when it came out, it was revolutionary because you used to have to buy point-to-point circuits where, serial 0/1 would connect here to serial 0/1 over here, and that interface is used up. Well, with frame relay, you could have one connection come in, and it can connect to a whole variety of things through virtual circuits, technically permanent virtual circuits. And that's where you pay the carrier, and you would say, hey, I want to have my site here in Texas, where Network Chuck is at, connect to my site here in Arizona. And I want to have let's just add another site. Let's add Las Vegas, where our friend Keith Barker is at. That'll connect in here to our site in Arizona, and we might as well have it connect right here, right? The way so when you're sending traffic to the carrier, right, you have to be able to identify which site it's going to go to, and the way that they do that is through DELCs, Data Link Connection Identifiers. That's the frame relay topology. It is frame relay's version of MAC addresses, right? In the WAN connection world, there are no MAC addresses. In serial technology, right? Serial links. There's no MAC addresses. So you need something that fills that role, and that's what the DELC is. The reason it's so confusing is because it's backwards of what people think. We're used to saying, like, let's just say this guy is DELC 1 and this guy is DELC 2, right? We're used to saying, okay, I'm coming from a source of 2 and I'm going to a destination of 1. That's not how DELCs work, okay? That's how MAC addresses work. The way DELCs work, I killed our WAN link. The way DELCs work is you go to the carrier and they'll say, hey, you'll be Del C, let's just say 102 over here, right? And on this side, they'll be like, you'll be Del C 201. So the way it works when you're transmitting, Texas will say, I'm going to send some traffic to Arizona, and you configure this as an administrator. You're going to say, I'm going to send it to a destination of 102, which is like, what? Don't think of it that way. Think of it like going to the airport, and this is your gate, right? I go to gate 102, ding, now boarding 102. You get on there, you fly through the air, and when you land, you look behind you, and you're like, oh, I came out gate 201, right? You land on 201. It's so down here you might have, 401, and let's just put 104 over here. If Las Vegas wanted to go to Texas, it would go into 401, and as it's coming out, it would come out on 104, right? It's this weird, bizarre one. It would have maybe 501 that would get it up to Texas, and 105. Now, I'm writing it this way to make it easier, like 105, 501, because it kind of flips it backwards, right? But in the real world, it could be anything. It could be anything you want. It could be anything the carrier wants. It all depends on how you negotiate it with them, right? So that's the idea of Del Cs. You can kind of see why I was like, that it can be a big topic if you go there. Okay, 1 minute left. Let me just see how many more I can jump in here. Wow, there's a lot of people. Are you listening to me when I'm talking? I'm telling you about frame relay Del Cs. Are you just totally kidding? Chuck is okay. Chuck, man, Chuck, you stole the show. It's like Elvis just walked in, and it's like, hi, Chuck. So welcome, Chuck. And it's okay, Chuck. It's okay. You can, if you want to steal my show. Is frame relay tested on two? No, yes. Sorry, scratch that. I thought you were talking about the new exam. The new exam does not have frame relay. The old all-in-one CCNA exam does have frame relay. Snow. What's the thing you're looking forward to in the next couple months? I have two kids yelling around me. We'll rewatch once they're in bed. Good. Okay, so I'll end with Kevin's question. Kevin, thank you. End with Kevin's question. The thing I'm looking forward to most in the next couple of months is honestly solidifying my direction. So, and that's being brutally honest. I am in a new world of social media, of posting YouTube videos. I run a company called Via. It has 33 employees, and that's obviously busy. I do these live streams. I have 7 kids. It's like there's a lot, and right now it's like the time in a day has come down to where it's just like sliver. And what I'm finding is I'm not getting the time I want to put into the things I want. So I'm like, okay, the plate is full. That's my next couple of months. What goes? What's the thing that I can pour my all into, and do it really well. So that's honestly that's what I'm looking forward to in the next couple of months, is really making a lot of those hard decisions. Yes, 7 kids. I know, unbelievable, right? 2 of them sitting right here. They ran the quiz. It's not their fault. I blew up the quiz. Okay. All right. That's it. Thanks, guys. I'll see you soon.